My name is Shashi Rivankar, and I represent a company called VALUESCAPE. This is a relatively new company. We started developing this product about 3 years ago, and we're going to go live with this product in the market January next year. So I'll show how we use Mathematica when we developed this product and designed the product, how we decided to integrate Mathematica into this product. So I'll start off with some of the few slides explaining how the product works. And then while I show the parts of the product, I'll also show where we integrated Mathematica. So this is about the company. What we want to do is we are in the real estate space. The real estate appraisers are the people who eventually tell the lenders what's the value of a house, residential appraisers. They have the final say as to what's the value of your house. Without the appraiser saying this is the value, the lender will never sign off on a loan. So the appraiser plays a very important part. And the industry today is, the way the appraisers come up with the valuation is they have a method called sales comparable method. Basically what they do is they find out what are the closest possible sales in those areas, and they do some kind of average, do some adjustment of the values. But what we are bringing to the table to the appraisers, we're trying to change the industry and bring more analytical tools in the industry, is by bringing more data and more analytics and help the appraiser come up with a real valuation. So this is our motto, this is our mantra, that we want to help the appraisers to do the proper evaluation or proper valuation of a collateral, which is a property. We were incorporated in May 2013. We have 40 plus US patents pending. We are dealing with the valuation risk and the information overload for the appraisers. Basically, what we are saying to telling the appraisers, you need to look at the data, you need to look at the analytics. There needs to be transparency. There needs to be credibility and supportability. This is important for the lenders, the people who consume what the appraiser produces. They are the ones who are going to consume this, and they need to have the report, a credible report, and findings in the report that are supportable. That's important for the industry. And our approach has been to provide tools to the appraiser which are mobile, have analytics, innovative analytics, and provide audit trails. The last part is very important for the lenders. And basically, it's right now the app is available in the App Store. Under that logo, it's called Valuation Navigator. And yesterday, we won an award for the technology from Wolfram. And we thank Wolfram for this. Our buzz, we have been talking to a lot of people in the industry. And these are some of the quotes that we heard from people, from the leaders of the industry. Coming down to the technology. The technology that we have built is we leverage the mobile cloud computing technology. The appraiser uses iPad. The technology is available on iPad, which is a big leap for an appraiser. They're used to going out in the field, writing on a piece of paper, coming down to his office, entering in his desktop computer. That's a big leap, because now with the app, they can do the complete report right out in the field using the mobile technology. The mobile technology, the app is supported by the cloud, what we call the Valuation Navigator Web API. And it's basically it's the internet connectivity between those two that helps the appraiser look at the data, look at the analytics right in his iPad. And we have a security around it. That's one of the important aspects that needs to be secure. And if you look at the cloud side of it, this is our architecture in the cloud. We leverage Microsoft Windows Azure cloud technology. On the top, you'll see the API. That's what exposes the entire cloud functionality out to the mobile app using the web API. Those are the exposed interfaces. Behind the scenes, there is the Microsoft Service Bus. Service Bus is the one that distributes work. So the web APIs don't talk to the servers. They talk to the Service Bus. They drop data. It's like a queue. They drop the data, the request in the queue. And then we have the services sitting behind the scene. On one side, we have order and data services. Those are set of so-called cloud services in Microsoft terminology. There are a set of servers that are scalable up and down whenever we need it based on their load. They will read the inputs from the service bus. They will do the computation. If required, they will go out to our external vendors. We read data from multiple external data vendors. We get public records, we get MLS data, we get plat maps, we get flood maps, we get cost data, and so on and so forth. And on the other side, which is, I think, more relevant for this talk, is we have a computational service. On this side, we have data service and other thing, and order services. On the other side, we have the computation service, where we leverage Mathematica. So on that side, you can see we have a set of virtual machines that run our code, and those machines have Mathematica installed on them. And that code leverages what the Mathematica services provide. And you can see in between, we need to persist the data, and we use MongoDB. That's our database of choice. And if you look at the app itself, this is what the app looks like in the iPad. Appraiser will see his orders, and you can see how it's designed. There's a left-hand side menu. There's the orders you can see. You can select an order and start working on the order. When I say order, it means really an appraiser got an order from a lender saying that I want you to appraise this property. And you can see here, once the appraiser picks up a property, the address of the property is down below there. And then you can see the first thing that the appraiser does is looks at the subject property. We directly show in the app the data we collected from the external vendors, the data vendors. We show the data to the appraiser. The appraiser himself doesn't have to go out and get the data. It's all integrated. And it's overlapped on the map here. We will support, of course, all the maps, standard maps. In addition to the standard data, there is something called flood maps. It's one of the deliverables that the appraiser does to the lender, because the lender needs to know, is this property in a flood zone? But there is a risk otherwise. So that's why we provide the flood information, and this property is not in a flood zone. There's something called plat map. This is when there's a new construction going on, and the builder has a map that's certified by the city, saying that this is the plat map. So sometimes the lenders take a look at it. It's all integrated. And of course, we have navigation too, because it's on iPad. Now, this is where the power of Mathematica really comes in. Early in our product development, we decided to use Mathematica because we looked at its functionality, how its interfaces work, and we decided to leverage Mathematica. And you can see one of the things we do is the appraiser needs to define, before he comes up and to this property and say, what's the value of this property, he needs to define something as his market, what is called neighborhood. And what we do here is, you can see there's the icon out there that's for the subject, that's your subject property, and around that, we pull the data from the data providers, like there's something called MLS. All the realtors, they drop the data in those systems. We pull that data. We also get data from the counties, we call public records. We put it all together. And we show that information there. And you can see there's what we call a heat map behind the scenes. It's a heat map that we use Mathematica. We basically compare the subject property, its characteristic, vis-a-vis all the other data points that we got, all the information about other properties. And we compare them and say, how similar or dissimilar is it to the subject property? And we display that as a heat map, and we show the colors so that we try to make it simple for the appraiser. Appraisers are not mathematicians. They need simpler tools. So that's where the power of Mathematica comes into picture. So basically, this is one of the density plots we show, and then we just simply display how very similar, dissimilar. And the appraiser can decide based on this, what is my market? Because now you can see here around that subject, and typically appraisers need to stay around the subject, because you can't pick up market that's far away from the subject. But your market sometimes can be divided into two different parts. They're not necessarily connected. They may be separated. And that's allowed. And this gives the appraiser a good idea of what his market is. And now he can decide now he can define what his market is. And to show you the power of Mathematica, the colors that you see here, how similar or dissimilar these properties are driven by these parameters. And what we call a heat map criteria. So basically, appraiser says, look, in my area, because I'm the expert in this area, and I know in this area, age doesn't matter. age of a house doesn't matter. What matters is how much is the GLA. It's called gross living area, how much is the living square foot area. And you can see here in this case, I've made everything else 0. I've made GLA 10 and then age 10 here because I want to see what if the age was a factor. And you can see here now there are a lot more reds. Because now, that means now these houses are more dissimilar to a subject property because now age is a factor. Whereas in the earlier one that we saw, age was not a factor. So you can see how we can give visually clues to the appraiser what his market should be. And I put a little a bubble there that says where we use Mathematica. And then once the appraiser says what he's looks at his market and say, okay, I need to define my market, the appraiser will, this is iPad, the appraiser will use his finger or a stylus and define and draw his boundaries. And you can see we allow the appraiser to define multiple boundaries. Now he's decided B1 and B2 is boundaries. And then what we do is, I as an appraiser would say, okay, I've drawn these 2 boundaries, but are they similar neighborhoods? Are they different neighborhoods? And then we have tools there where say compare. Again, we use Mathematica. We do behind the scenes. It goes out to the cloud. It does the comparison of those 2 markets and spit it out here as images. Now we can compare. I've skipped some steps in between. But one of the important things for the appraiser to know is, okay, I've drawn these markets. But within those, what I'm doing with this drawing of the boundaries is I'm defining a geographical area. But it is quite possible within that geographical area, there are some properties that are not fitting in your model. It doesn't fit in your style. And rather than the appraiser trying to find out those himself, we use Mathematica functions to say which properties are dissimilar vis-a-vis your whole market. And we spit it out here, and you can see how we show graphically the appraiser. And so look, your market, the regions that you drew, can be divided in 2 parts. There's a low-end market, there's a high-end market. You can decide as an appraiser, oh, I don't want to include high-end markets, but you can see here how it skews up the values. The appraiser can decide, okay, I'm going to stay with the low-end market because that's my market. And again, we leverage Mathematica here. One of the things that the appraiser has to do later on is in his report to say, he has to answer question, is this property similar to the rest of the properties? Is it similar or dissimilar? And we just show him visually, does it fit? We use each of the characteristics, like we call GLA, gross living area, number of bedrooms, bathrooms, number of parking spaces. Those are the characteristics we use to tell the appraiser, does it fall into your 2 sigma boundaries or not? So that's a visual clue for the appraiser, rather than just tell the appraiser whether it fits or just give numbers. We also leverage Mathematica to do trend analysis vis-a-vis the data we got. Says one of the questions the appraiser has to answer is, how is the neighborhood behaving? What are the trends in the neighborhood? Are the prices going up? Are the prices going down? Simple statistics. And we use leverage Mathematica again. So we look at the data, we feed the data to Mathematica, and it spits out these charts. And it's integrated. And that's another set. When it comes to the appraiser, I mentioned earlier, the appraisers use sales comparable as the major method they use to come out with value. We have now introduced with the app the multiple regression because we have the data, we have the capability to the regression. They also have a listing comparable approach sometimes they use. There is also a cost approach sometimes they use. But the major one we're introducing is the multiple regression. And this is where the power of Mathematica comes into the picture. What we do is in the app itself, you can see here, as soon as you go to the regression module here in the app, what we do is these are the characteristics of the property that we could use in the regression. And based on the knowledge of the appraisal industry, these are the characteristics we have determined that are potentially can be used. Some of the characteristics we say are not available for your regression because we don't have data. The data that we got from the data vendors, there is no sufficient data. So we, instead of the appraiser running a regression and then coming out with the wrong value, we right away say, you can't use this. And you can tap on it and find out why it's not available. But otherwise, we say, these are the 5 characteristics that are available to you. You can use them. So we kind of do a guided regression, as you can see here. And all you have to do at this point, now the appraisers, as I mentioned, they're not mathematicians. You run the regression, and what to do with it, there's always a question mark. So we try to make it as simple as possible to them. And when you run the regression and you get an output, there is always a process involved. How do I interpret this result? So what we try to do is we try to make it simple for the appraiser. What we do is, once you run that run button, we go out to Mathematica, run the regression, come back, and then we apply the knowledge that we bring to the table, and we say, look, these are the potential errors in your model. If you just adopt this model here, these are the errors you'll end up with. For example, in this case, it says the age. Typically, in the appraisal industry, you'll find any market in the US, the value of the house decreases as more aged it becomes. But this model came up with a positive value. That means it said your value of the house will increase based on this age. That means there's something wrong with the model. So we bring out those ideas, the alerts here right away. And then this is the actual output of the regression. We show the regression characteristics here of the output. We say the R square. We'll give them a little bit more readable names. Rather than calling it R square, we call it model's predictive power, so that these are the terms that the appraisers can understand. Instead of calling R square, adjusted R square, we call it adjusted predictive power, spread of data, accuracy of the model, the amount of data available. And at the end of this, you can see a little bit of composite reliability score, we call it. The idea behind this is it's kind of a composite value based on this the 6 characters above. It's a little algorithm we apply to say what's the composite value, rather than look at those values individually. We say this is the composite value, so that when you're doing an iterations, you just look at that value and say, is it increasing or decreasing? So you just look at one number. It's a tool that we provide to the appraiser. But otherwise, you can see here we show those variables, and you can see we show some of those things in red and green. The green ones are good ones. Everything seems to be good. P-value is good, less than 0.05. Anything that's above 0.05, 5% is for the limit we use for the predictive power. And then at the end, we have a little bit thing there that says what's the value by regression for that property. And we also show 2 more extra things, what's the best 5 sales and best 10 sales. This is just for the appraisers to know, if I just take the best 10 sales of best 5, what should be the value? But typically, they will end up using the regression value as a concluded value, as you call it. But having come to this point, you cannot adopt this model right away because there could be problems. And as we saw there are some red variables out there. So the appraiser would typically do iterations. And to do iterations, there are several methods. One of the methods, of course, is I see there are some outliers. I might want to take out some outliers because they don't fit into my model. So we show the plot here, and you can actually go and tap on a point and look at what the point is, what are the characteristics of it, why is it outside, why is it inside. You can take a look at it. We also show Cook's distance, just in case somebody is interested. Or you can take a look at the entire data set and say, OK, I don't like this value. I can sort it and say anything outside 30% of the predicted versus the actual price, take it out. So I can apply filters here. Or the third way is we provide a trim box, which at this point is the one that the appraisers normally use because it's easy to use. We provide a trim box. You just use a finger to draw a box inside, outside, keep everything inside. Everything that's inside is what is used for the next iteration. And you run the iteration. And if the appraiser wants to know why is that in red, we provide explanation out there. We also provide a residual plot. If somebody who is more advanced in regression is interested in, we provide this residual plot. We also allow iterations, so we can now take a look at it and say, no, I want to go back to the original model because I deleted some point. I want to go back to the original one and start all over again. You can do a reload and restart. We also allow appraiser delete iterations because I don't want to see that in my comparison. Compare iteration, compare your models. And at the end of it, the appraiser says, oh, OK, I'm done with this. I've done 5 iterations. This is the model I like the best, because it gives me the right, everything seems to be good, everything is green. And then they adopt the model. And one of the things they do here is The regression used these variables and came out with these coefficients for these variables. And these variables are used in the next valuation model, which is the by sales comparable. One of the things the appraisers do is they say, okay, which I'll show in the next slide, is I want to compare this house to another house. That house was sold for $300,000. But that house and this house, there's a difference. This one has 3 bedrooms, that one has 4 bedrooms. So I'm going to adjust the price of this house because there's one less bedroom by using a value of that bedroom. So they do an adjustment. This one spits out what those potential adjusted values are. So there's another side benefit of using regression. And I can run regression. At the end of it, I adopt that model. And then we move on to the next valuation method. So that was the regression, and where we leverage Mathematica substantially to run the regression. One of the things we are doing is we are bringing optimization techniques in regression so that the appraiser doesn't have to go through iteration, hit a button that says optimize, and then you get optimized. The next one is sales comparable. This is a typical method the appraisers have used, and it's also supported by us. And this is a kind of standard functionality where we show the information about comparables. They will pick up the 3 best or 6 best appraisals. They do the adjustments. This is the screen where they do adjustments and come up with a value. There's a cost approach we support. We also use Mathematica here. The photos are integrated. You can take your iPad and take the photos. We do integrated sketching. At the end of it, you have used 4 different valuation methods. And then the appraiser reconciles and says, okay, based on these 4 methods, my value of the house is so and so. This is where the appraiser decides for himself what the value of the house is. And then all that information goes out into something called form, and this is the form that gets delivered out to the appraiser. In terms of the Mathematica integration, just to come back to that, pretty straightforward. We have .NET Cloud. We use a Mathematica .NET Link library. That's how we reference. What we have done is we have encapsulated Mathematica into our own class. There are 2 potential styles for calling Mathematica in your .NET code. You can call inline calls. So call your Mathematica engine directly in the last line you see. You call evaluate. Or one of the methods we follow is put our scripts into an external file. So all the commands are in the external files with parameters. And then later on, we use that, we call that external file, pass in the parameters, let Mathematica evaluate. And that's the presentation. Thank you for your time. I know this is a slightly different topic rather than the very, very intense technical sessions that you have.